This video is about review for area and volume in calculus. 1a. Consider the function f of x equals the square root x squared minus 1, where x greater than equal to 1 less than equal to 2. Sketch the curve y equals f of x, clearly indicating the coordinates of the endpoints. First of all, we will go to a graphing calculator to sketch f of x equals the square root x squared minus 1. Go to y equals second x squared, then x squared minus 1. Graph. Since x is greater than equal to 1, less than or equal to 2, we will change the window. Go to this window from 0 to 3, and y less from 0 to 5. Graph. Coordinates of endpoints. When x equals 1, y is 0. When x equals 2, y is the square root of 3. Plot these 2 points. This question has 2 marks. 1 mark for the shape of the graph. Second mark will be the coordinates of the endpoints. Let's go to 1b. Show that the inverse function of f is given by inverse of f of x equals square root x squared plus 1. Remember, we will use the escape button to figure out this inverse function. Exchange xy. Solve for y. Then change y into inverse function symbol. So for f of x equals square root x squared minus 1. F of x is y equals square root x squared minus 1. Exchange xy. X equals square root y squared minus 1. Then solve for y. Square both sides. Then isolate this y squared. X squared plus 1 equals y squared. From this graph, we can figure out the domain of f of x is x greater than equal to 1 less than equal to 2. Range is y greater than equal to 0 less than or equal to square root of 3, which means y is positive. Therefore, for y equals positive square root x squared plus 1, inverse of f of x equals square root x squared plus 1. Let's go to 1c. State the domain and the range of inverse f of x. We know for f function, domain is greater than equal to 1 less than equal to 2. Range is greater than equal to 0 less than equal to square root of 3. So for inverse function, we will switch xy. In other words, we will switch domain and range. Y greater than or equal to 1 less than or equal to 2. X is greater than equal to 0 less than or equal to square root of 3. Let's go to 1d. The curve y equals f of x is rotated 2 pi around the y-axis to form a solid of revolution that is used to model a water container. Show that the volume of water in the container when it's filled to a height of 8 meters is given by this formula. We know this is the graph of f of x. Rotate about y-axis. Formula booklet, we know we got to use this formula. Since we already figured out inverse function equals the square root of x squared plus 1. This means x equals square root y squared plus 1. So we get integral from a to b pi y squared plus 1 dy. When it's filled to a height of 8 meters, is given, which means this b is h, a is 0. From 0 to h, pi y squared plus pi dy equals bracket pi times y to the third power over 3 plus pi y from 0 to h. Then substitute h for y. We will get 1 over 3 pi h to the third power plus pi times h. Take a pi out. 1 over 3 h to the third power plus h. Let's go to 1e. Hence, determine the maximum volume of the container. When h equals square root of 3, we have a maximum volume. We will use this formula. Pi times 1 over 3, square root of 3 to the third power plus square root of 3 equals pi times 1 over 3 times 3 square root of 3 plus square root of 3. Reduce. We will get pi times square root of 3 plus square root of 3. So final answer is 2 pi square root of 3. Let's go to 1f. At t equals 0, the container is empty. Water is then added to the container at a constant rate of 0.4 meter cubed per second. Find the time it takes to fill the container to its maximum volume. T equals maximum volume over this rate, 0.4. So equals 2 pi square root of 3 over 0.4 equals 27.2 seconds. Go to 1G. Find the rate of change of height of the water when the container is filled to half its maximum volume. We know volume equals pi 1/3 h to the third power plus h. We will take a derivative of both sides with respect to t. dv dt equals pi times 1 over 3 times 3h squared dh dt plus dh dt. Let's take dh dt out, then simplify. we will get pi times h squared plus 1 dh dt. So dh dt equals 1 over pi times h squared plus 1 times dv dt. We already know dv by dt equals 0.4. We need to figure out this h. When container is filled to half its maximum, half its maximum will be 2 pi square root of 3 divided by 2 equals pi square root of 3. We will set up volume equals pi square root of 3 to figure out h. For volume, it's the pi 1 over 3h third power plus h equals pi square root of 3. Reduce pi both sides. 1 over 3h third power plus h minus square root of 3 equals 0. By equation solver, we will get h equals, let's go to y1, 1 divided by 3x to the third power plus x minus square root of 3. Then quit, go to math, equation solver. Alpha trace, go to y1, enter. We know the height is between 0 to square root of 3. Let's estimate the value for h is 1. Alpha, enter. H equals 1.1818. H equals 1.1818. Then we do the substitution. 1 over pi 1.1818 squared plus 1 times 0.4. Quit. Then press X, enter. We will get this X, pi times this square plus 1, enter. Then get reciprocal of 8 times 0.4, enter. Answer is 0.0531. So answer will be 0.0531 meter per second.